This is the GEM 1400s flash. It's our transmission electron microscope here at Oxford Brookes. The GEM 1400s flash has the usual features of a transmission electron microscope. Here is the column of the microscope. At the top of the column, there is the electron gun. The gun generates an electron beam that travels inside the column of the microscope, which is kept all under vacuum. At this level here, you insert your sample. So the beam goes through your sample, and then it projects an image of your sample on a screen found here. Most of the time, you will be using not this screen, but the camera that is found under the microscope. So this screen will be lifted, and then the image will be projected onto the camera here. The GATN one-view camera is a very important part of the TEM system we've got here at Oxford Brookes. It's a 16 megapixel camera. It's a very expensive and very good camera. This camera is placed under the column of the microscope, and that's where it has to be. Sometimes when you're sat at the microscope, you may find that your knees will get quite close to the camera, so beware of not hitting the camera with your knees. Along the column of the microscope, here and here, there are magnetic lenses and also small metal apertures. The lenses and the apertures control the shape of the beam, and they make sure that the beam travels nice and straight down the column of the microscope. This is very important for resolution. There are two computers linked to the TEM. This computer down here controls the microscope and is linked to this screen. This screen shows the microscope controller software, TEM Center. This computer down here, next to the microscope, is linked to this screen. It controls the camera. These are the windows that you are likely to use in the microscope software. On the left-hand side, you will see the beam condition and the spot size, as well as the stage position and the magnification. The stage controller window allows you to change the stage position by clicking and also change the tilt angle. You will use the nanospace map window to save positions that you like in your sample so that you can then go back to these positions later on. You will use the beam controller window to switch the HT on and off, and also to switch the filament on and off. This window shows you a diagram of the microscope with the vacuum conditions in different parts of the microscope. The camera is controlled by the digital micrograph software. If it's not open, you should open the digital micrograph software using this icon here, GMS3. Once digital micrograph is open, click on TEM imaging here. This will give you the options for TEM imaging. On the left-hand side here, digital micrograph shows you a little diagram of the column of the microscope. So here it tells you the conditions of imaging with the KV and the magnification, and it shows where your sample is. It shows the screen, and also it tells you that the one-view camera is not yet inserted in the column. Very importantly, down here on camera monitor, you will see the camera temperature. You should only use the camera if the temperature of the camera is at -5 degrees Celsius. These three here are the control panels of the TEM. The tracker ball allows you to move the sample in X and Y to look for a nice area to image. These two panels here allow you to control the magnification, the brightness, the position of the beam, and also to focus. If you're an experienced user, you will also do microscope alignment using these panels. An interesting feature of these panels is that they go to sleep. So when all the buttons are black, like this, it means the panels are asleep. To wake up the panels, All you need to do is press any of the buttons only once. You will see that there will now be lights in all of these buttons. The controls you're likely to use the most are the brightness, the focus, and the magnification. These two X and Y wheels here, they allow you to change the position of the beam. Next to each controller wheel, there is a blue indicator light. This light indicates whether that particular control is on fine mode or coarse mode. When the light is dim, the control is on fine mode, and if you press the wheel, then the light becomes brighter, so you've switched from fine mode to coarse mode. So it's on coarse when the light's bright, and it's on fine when the light's dim. This is also valid for the focus wheel. So I switched from fine focus to coarse focus, and now I'm going to switch back to fine focus. And in the X and Y multifunction controllers, I'm switching from fine to coarse for both of them.